We saw in example 13 where we could solve for x to give us a production level that would yield a specific profit. We can also do that with revenue equations. We could set a desired revenue, set our revenue equation equal to that value, and solve. But a question that kind of comes along with this is where all these different equations come from. So what we want to do is revisit a problem that we've seen before, but add some additional steps to it, where now we're going to generate a revenue equation given some price demand equations. So we have a store that recently sold a particular item for $10.95 each, and at that price they sold an average of 70 items per day. Then they raised the price to $14.35 and sales dropped to an average of 63 items per day. Assuming the relationship between price P and demand X is linear, we want to generate two price demand equations, first with price as the independent variable. We've done this before by using the command line through, and we'll input price as our independent variable, our X variable, and demand or units sold as our Y value. And we'll generate that linear equation in slope-intercept form. Rounding our values to 2 decimal places, we end up with the equation x equals negative 2.059 times P plus 92.54. In part B, we want to do the same thing, but use demand as the independent variable, meaning we'll just flip these values around. Our first point will be 70, 10.95, and our second point will be 63, 14.35. We'll get a new linear equation in slope-intercept form. Rounding those values, we'll have P is equal to negative 0.486x plus 44.95. In part C, now what we want to do is generate an equation for total revenue. Revenue is always equal to units sold times our price per unit, or price per item. In this scenario, X is our units sold, and P is our price per unit. But what this would give us now is an equation with two different variables. We want to substitute in one of the expressions from part A or part B so that we can rewrite this with a single variable. What we'll do is take our price equation that we generated, our price demand equation, with demand as the independent variable, and substitute that in for P. Then distributing that value for X through will give us negative 0.486x squared plus 44.95x. And we've generated a revenue function. We have a quadratic equation that we get by taking our price demand equation with demand as the independent variable, multiply that by x, and now we can solve a problem like part D, where we want to use Wolfram Alpha to find the production level that will yield a total revenue of $1,036. So to do that, we'll solve our revenue function, negative 0.486x squared plus 44.95x equal to 1,036. We get two different values. again, rounding to the nearest whole number since we're talking about units produced, this will give us two solutions of approximately 44 or 49 units. Meaning, when this store is selling either 44 or 49 units, then they're going to generate that total revenue of $1,036.